Thank you.
Yes, bro.
I just get an email.
What email is it?
The email of an opening project. The project is about to build a bridge.
The bridge?
Yes, the bridge at Sri Kembangan. It is from JKR. And what do you think?
I think it's a good opportunity because it's a multi-million project. So I think we should grab the chance
Yes.
and go talk to the boss. What do you think?
Yes, I think it's in the same way.
What are you waiting for?
Let's
go.
go.
So you may start your presentation for your project.
Can we start our slide now? Alright, madam, as you can see, our company name is DK Construction Sendirian Berhad, and our company number is 2152038. And as you can see, we are the certified company from Malaysia. Our SIDB registration is grade 4B04, and our registration number is 012-016-0303. And we have a lot of experience in construction. We have already built the multi-billion projects such as the tallest building and the largest bridge in Malaysia. So I think we are the right company that able and capable to grab the task and finish the job within the time. So without further ado, I will call one of my engineer to proceed with this project. Please, Mr. Gushari. Let me proceed.
Okay, for this Sri Kembangan location, there are three different bridges that we can go. There is the truss bridge, the beam bridge, and the arc bridge. But for this certain location, after we research about the geology place, we suggest the arc bridge. Okay. For the arc bridge, they consist of concrete arc bridge and steel arc bridge. And we have made some other research and we choose the steel arc bridge because of the geology and also because of the cost. Okay. Arc bridge have been very popular and widely used since ancient times. The reason for this, the arc bridge are aesthetically pleasing as well as economically feasible. Furthermore, in some cases, it is the most preferable solution. The arc is the basic structural element of this bridge, and its shape is usually circular or parabolic. One of the aspect design process is to ensure the stability of the whole structure, since instability may occur before the stress reach their allowable limit. Therefore, one of the designer objectives is to select member section that maximize the buckling strength and thus the total load carrying capacity. Geometry unloading, I hand over again to our engineer, Mr. Gushari.
Thank you, Mr. Top. So I'm going to proceed with the geometry. The notation and the loading of the arc bridge structural model considered are illustrated in this figure, as you can see here. The bridge is symmetric and is composed of three major structures, which is the deck girder, arc rib, and also the vertical post. The deck girder has a constant double T cross post. The arc rib has circular or parabolic axial configuration and a constant box-shaped cross section. The rib is pinned in case 1 or fixed in case 2. At the abutment, the deck girder and the arc rib are rigidly connected at the ground, thus there is no axial forces on the deck. The posts are located every 10 meters and pinned with constant cross section. Okay, as you can see, this is the deck girder, and this one is the vertical post, while this one is the arc. Okay, one of my engineers will explain how and when the buckling will happen. So without further ado, we'll invite my assistant engineer. Thank you, sir. So let's see this one. So what is this? It's based on the mathematical formulation of section 2 and its computer implementation. The critical load for various value of the considered parameter are computed. the two lowest critical loads and their corresponding mode shape are formed, which we can see. This one is the undeflected one, the bridge. Then here all is because of the buckling effect. So what being buckling? So I'm going to explain it after this. First, this is an example of a structure. Then you can see here got one load, which is axial load, which is called axial load. And for buckling happens because of a load experienced by the structure parallel to the structure actually. So this one is called as axial force. Then the buckling effect bring the shape of like this. So for our structure to be stable, our axial force shouldn't be more than the P critical. So we got one formula to calculate all this. So for calculate P critical, we got a formula which is P critical equal to pi square AI over L square, which is E is Young's modulus, and I is moment of inertia. So yeah, and then so for all three, this thing was dead up, and for the so we consider buckling for all the three structure, which is a deck and the post and the arc. So we should make sure that the axial load acting at every point shouldn't exceed the P critical, which we will measure later. So yeah, buckling is considered one of the major factors that will affect the structure of the bridge. So I think our team has analyzed it that our structure is very suitable for building a bridge at the Sri Tumbangan. Yeah. Then I pass it to Mr. Rashran.
Okay, for the next section is material selection. As you can see, we have compared two types of material. For the first material is steel, and the second material is concrete. Okay, as we can see here, concrete is a composite material that consists of cement, sand, gravel, and water. So it has a relatively high compressive strength but lack of tensile strength. Concrete must be reinforced with steel rebar to increase a structure's tensile capacity, ductility, and elasticity. For steel, we can see structural steel is extremely strong, stiff, tough, and ductile, making it one of the leading materials used in commercial and industrial building construction. So this is one of the factors that we choose steel as our material, because we can see in terms of strength, steel have the advantage. And for the cost, we also can see the price of steel can fluctuate. It typically remains a less expensive option compared to reinforced concrete. Recycling usage makes the material much cheaper than when we compare to other materials. And for the cost for the concrete, we can see a large cost benefit to concrete is the fact that its price remains relatively consistent. On the other hand, concrete also requires ongoing maintenance and repairs, meaning added costs show up in lifetime. So we can see here, steel is cheaper, but concrete, the cost is stable, but it has additional of cost with its maintenance throughout its lifetime. Okay, I think that's all for the material selection. I will pass back to Mr. Hussain.
Thank you, Mr. Rajan. So I will proceed with our budgeting for the arc bridge. Okay, so we are going to the description is content, which is the arc, head wall, wing wall, and also the footing, which costs us about $340,000. ringgit actually. And the watering costs us about 20,000 ringgit. Installation of contact, as you can see here, also 20,000 ringgit. Structural excavation, unit per cost is 1,550 ringgit, and we did about 1,000 meter, and which costs about 50,000 ringgit. Structure backfill about 1,500, which costs us about 100 ringgit, and the full cost is about 150,000 ringgit. Concrete pavement section, 100 ringgit costs us, and we need about quantity about 206, which costs us about 20,622 ringgit. And the structure concrete, 800 with a quantity of 350, which costs us about 280 ringgit to 280,000 ringgit actually. And lastly, the traffic barrier, 75 ringgit, and the quantity is 110, which costs about 8,250 ringgit. So at this stage of the construction, the company need to pay us 90% and keep for the 10% for the specific year. It's actually about 10 or 5 years. And the subtotal is 799 ringgit, 985 ringgit Malaysia, and the contingency 159 ringgit, 997 ringgit Malaysia. And the total cost for this project, 959 ringgit, 959,982 ringgit Malaysia. So that's from us, and I will give back to my companion, Mr. Tak. You may proceed to the next slide.
Thank you, Mr. Kushari, for the cost handling. Letakkan cost. Pause. To conclude our presentation, the alternative proposed here have been carefully studied to determine the most functional structure and cost-effective at the proposed bridge location, and with consideration given to the following factor, that is constructability, maintenance, cost, and aesthetics. The overfill steel arch bridge structure is preferred because it minimizes the duration of construction and it meets the stage construction requirement. It is also the most cost-effective solution. It will require minimal maintenance throughout the life of the structure. Finally, this type of structure will be aesthetically pleasing and blend in well with the natural surrounding. For us, I hope our presentation can suit your interest regarding this project, and we are looking forward to work again with JKR. Thank you.
Hello, is this DK Construction Company?
Yes.
I would like to inform that you guys have been chosen for this tender. Congratulations. And now please come to our office tomorrow for the tender agreement. Thank you.
Welcome. Thank you for your consideration for us to get this tender.
Thank you.